sarcastically, I said, yeah, that's so good. I did amazing. And she said, yay, I'm so happy for you. You worked so hard. And I said, no, I got a 31. I failed very bad. And she said, girl. And I said, what? And she said, that's not bad. You got 6 less than. And I said, girl, I got a 58. And she said, see? Yay, that's amazing. Oh, wait, not on the test, right? The grade. Oh, I'm so stupid. She needs to lower her expectations for me. I'm not as smart as she thinks I am.
You just listed off names.
Oh.
See it?
Good morning, ladies and gentlemen. How are we doing today? Wonderful, wonderful, wonderful. Excellent, ladies and gentlemen. Please put away your phones. Please put away your headphones. Take out your computers and get ready to go. Big week this week, ladies and gentlemen. As we figure out if you know anything about what I've taught you lately. I got a chair. I will grab it. So, all lefty. Come on in.
You have to lock it like.
I know, but my LA
We can go.
Alright.
I only got centralization now.
Oh,
But look at this.
that's
Look
like
at this.
that's the beginning.
And do you know when it was posted? 2 weeks ago?
It was due 2 weeks ago.
It was
And you
posted
didn't-
2 weeks ago.
Oh.
It was posted January 11th. It's due today. And I started last night. I did this all last night. All of this stuff. Yep. I got a lot in.
Yeah.
Because it's due in the 4th hour. I mean, it's Mr. Nass, so like maybe he'll say like, no, it's okay.
Alright.
It's gonna make you sad. It's really sad. Yeah, but it's also Mr. Nass. So
You're gonna find out today.
I'm sure I can get it done in time. Not even.
Alright. Today, ladies and gentlemen, we're going to talk about doing some calculations with density and with specific heat properties that are physical properties. I've already done some with density, but we're going to introduce this idea of specific heat today too. On Thursday, ladies and gentlemen, you will have your Unit 2 test. So tomorrow we will do some reviewing. I will give you a list of topics and things, and then on Thursday we will take the test. Questions? Okay.
Questions are on the test.
I don't know off the top of my head. I'll go through that all tomorrow with you. I don't know off the top of my head. So tomorrow we'll talk about that, and I'll tell you what kind of questions and topics and things like that. So, all right, give me an example of 2 objects that are exposed to the same amount of heat but end up at different temperatures. So when you heat something up, 2 different objects, they get to different temperatures, even though they are heated up by the same amount of heat.
You just name any 2 things in a room.
What do you mean by that?
Like this desk and then the air around it.
Okay, but what temperature is the desk at?
Room temperature.
What temperature is the air around us at?
Room temperature.
So those are 2 objects that are exposed to the same amount of
Oh,
heat,
different
but they're at
temperatures.
the same
Oh,
temperatures.
okay.
I want to know
Okay.
how,
Different.
and again, think of heating things up, okay? And even though they've been exposed to the same amount of heat, they're not at the same temperature. Okay? They're not at the same temperature, even after being exposed to the same amount of heat. Leaf?
Something really big when it's really small.
Okay, like what?
Big metal block or something.
Okay, it is if you have two very differently sized objects. Okay? A very big object and a very small object, you expose to the same amount of heat. Very good. Good. Okay? Anything else?
The wood chips on playgrounds versus those burning metal slides.
Okay.
Oh my God.
Great example. Actually, I've never thought about that one.
What's the
What's that, Brindley?
tar thing on the cement?
Blacktop.
Yeah. You said like a black top versus like the wood chips. 'Cause, like, the
Okay.
black top's hotter.
Great example.
Or like the sand at the beach and the water at the beach.
Good, good,
I know,
good.
I'm
Now,
just saying,
we are on a roll, ladies and gentlemen. Okay, let's go back a minute. Okay, all right, the one that we were given. So if you're on a playground and you go down the slide on the playground, the slide gets very hot.
Specifically
Okay.
the metal ones.
Yeah.
Specifically the metal ones. Yes, good point. Plastic ones, not so much. But a metal slide gets really hot. But the wood chips that the kids are walking on, or that you're walking on, or whoever is walking on, they do not get very hot. Okay? Again, the point of the blacktop outside on a sunny day gets very hot, but the wood chips on the playground, again, not near as hot. Cool. Even though they've been exposed to the exact same amount of sunlight. Okay? What was yours, Miro?
Like the water at the beach and the sand at the beach.
The water at the beach and the sand at the beach. You get to a beach, you start walking on the sand, your feet are almost burning. But when you walk into the water, much cooler. Even though they've both been exposed to the same amount of sunlight, the same amount of outdoor temperature during the day. Okay? Very different temperatures in the end. How about something in your home? Something very practical. We want it to be this way.
Microwave.
What? What do you mean?
I don't know.
Furnace.
Food versus
Furnace.
in the microwave.
Okay,
No,
don't
it's-
stick your forks
no,
in the
it's-
microwave
it's-
if they're metal.
It's the bowl and then the food.
No, because it'll mess up your microwave if you shove metal in
I
there.
got it on fire.
Every time it's the bowl and the food. The bowl is always hotter than the food.
food.
I swear.
Okay, good. Now we're thinking along things that I was hoping we would get to. But even your one going back to the food in the container. Depending on the container that you put into the microwave, when you put food in it, or when you have food in it, and you use the microwave, it will heat up the food, but not the container, depending on what kind of container it is. Okay?
It's the other way around.
What's that?
It's the other way around.
Yeah. a lot
Your
of times it's
container
the other
heats
way
up and
around.
not your food?
Yeah.
Okay, but it's still the same principle, right?
Yeah.
You're adding the same amount of heat, you're getting very different results from it. Okay? The other one that I was thinking of, ladies and gentlemen, and you guys have done a nice job with this actually today, is think about your pots and pans. When you put them on the stove, you turn on the heat. What part gets really hot?
The metal.
What part hopefully doesn't?
The handle.
The handles. Handles are made out of what?
Well, it depends.
It depends. If they're made out of metal, they're going to get hot.
They do get hot.
Okay, get a different set of pans. Get pans that have a plastic handle or a rubber handle or a wooden handle. And they will not get as hot. Okay? They will not get as hot. Okay? That is one of the properties of matter. Some things heat up very easily, some things do not. Does sand heat up very easily? Yes. Does water? No. Okay? Both.
Specific.
Very good. That is what we call the property of specific heat. And that is what we are going to get into today, ladies and gentlemen, is this property of specific heat. Some things are very easy to heat up. Some things are very difficult to heat up. Now, it doesn't mean that you can't heat them up. What it means is that it takes more energy to heat them up. Okay? And that's what we're going to talk about. But before we do, ladies and gentlemen, I'd like to review a couple of things. Number one, density. Okay? We did the lab earlier in the year where we found the density of all those different objects. There were 4 objects, the same kind of material, different sizes. We found their densities by taking the mass divided by the volume of those densities. Okay? So again, remember, on your quiz, let me rephrase that, on your test on Thursday, there's probably a reason I'm going over this today with you, okay? So, on your tests, okay, we're going to use the formula density is equal to mass divided by volume. Density of the object is 45.6 grams. Its volume is 62.3 milliliters. First of all, before we go any further, 45.6, Nadia, how many sig figs in the number 45.6? How many sig figs in the number 62.3? 3. So how many sig figs would our answer have in this problem? 3. Multiplication and division. When you do multiplication and division, you find the number of sig figs in each of the numbers that you are using. You report your answer in the same amount of sig figs as the fewest number of sig figs. Since these measurements are both 3, you're going to end up with 3 sig figs. So we take our mass divided by our volume, ladies and gentlemen, and for this one we would get 0.732 grams per milliliter. Okay? 3 sig figs. We would round this last digit, the 2, depending on what number was after it. Okay? If the number after it was 4 or less, we would leave it as a 2. If the number after it was 5 or greater, we would move it up. I didn't write down what the number was. Maybe it was 7.7319. Maybe we've already rounded it up. But again, make sure you're checking and rounding your answer. Questions, ladies and gentlemen? Yes, no, maybe so. All right. Find the mass of a sample when it is placed in 50 milliliters of water and has a final volume of 94.2 milliliters if the sample's density was 2.31 grams per milliliter. So now we're looking for something different on this one, ladies and gentlemen. Now we're not looking for density. We are looking for the mass of the object, okay? Now, we could still use the same formula. Density is equal to mass divided by volume, okay? Why are we given 2 volumes here?
Find the difference.
Okay, just like in your lab, we found the volume by taking and putting some water in a graduated cylinder, adding the object to the graduated cylinder, and finding the new volume in the graduated cylinder. It is an easy way to find the volume of an object. It is called volume by displacement. So we have 2 volumes here, ladies and gentlemen, because we are going to need to subtract them in this problem, okay? The larger volume minus the smaller volume, or the original volume, will give you the volume of just the object that you placed in the container. That is going to go down here. Density is going to go right here, ladies and gentlemen, and then we are going to end up solving for mass. So our formula would look like this. 2.31 grams per milliliter equals X grams, X being the mass. You could leave it as M, I don't care, whatever variable you want. Divided by these 2 numbers subtracted. Again, the volume with the object in it minus the volume without the object in it gives you the volume of the object. So this ends up being 44.2. Now, to solve this, what do we have to do mathematically to solve this, ladies and gentlemen? Someone explain the math to me. What are we going to do? Please, 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 don't everybody go all at once. I can't understand it when you guys all do this. One at a time, please. Okay, we could do the parentheses first. Absolutely correct. But what I'm looking for is, what do we got to do to this problem right here to solve it? And ladies and gentlemen, again, because it is formatted differently, because it is done this way, density is equal to mass divided by volume. So our density is 2.31 grams per milliliter equal to the mass over, and you're right, we need to do this part in the parentheses first. So let's make that 44.2 milliliters. What do we do to solve this problem now? Okay, I agree with you. Now tell me why we're doing that.
To get rid of it on the side of the variable and add it to the other side.
Okay, we want to, I'm going to use a mathematical term here. We want to isolate the variable m. You've never heard that in math. Really? Anybody else never heard that in math? Isolating a variable?
Yeah. I do it all.
Okay, single it out, isolate it, get it alone on one side. So Levi is absolutely correct. The way we get m alone on one side, since we are supposed to be dividing it by 44.2, is we are going to multiply it by 44.2. Okay? That will cancel this out on this side. By the way, that's milliliters. And what we do to one side of an equation, we got to do to the other side. We got to do to the other side. So over on this side, I'm going to take this side times 44.2 milliliters as well. That will get us m alone. Okay? So we take our 44.2 milliliters times 2.31 grams per milliliters. What happens to the unit of milliliters here? Here and here. They don't square.
No, they cancel.
They cancel each other out because this is on the bottom and this is on the top. So they're going to cancel each other out, which is good because we want to be left with the unit of grams. Okay? We want to be left with the unit of grams. All right? Please understand, ladies and gentlemen. Right? Well, last week, Thursday, we took our Unit 6 test in the second half of chemistry. The kids are in Chemistry B right now. We were into doing gas laws. A lot of problems like this, ladies and gentlemen. A lot of problems where you had a variable, you have to end up getting it isolated, singling it out, getting it alone, however you want to say it, and then solving for your problem. And the students were struggling, not with the science of doing it, but with the math of doing it. So again, ladies and gentlemen, I hope that some of the math that I'm talking about is something that you are familiar with, because to be honest, it gets worse in here in math as we go on in this course. Okay? Second semester is a lot of math. The first is not. So keep that in mind. Okay? So, again, we end up multiplying these two numbers together to find the mass. Our mass ends up being 102 grams. Again, 3 sig figs here, 3 sig figs here. Our answer in 3 sig figs as well. Questions? Every time you do a math problem on a test from here on out, a point of your grade will come from units and sig figs. You have to have the correct unit. You have to have the correct amount of sig figs. The unit for mass is grams, ladies and gentlemen. Questions? Okay, so the first one we solved for density. The second one we solved for mass. The next one, ladies and gentlemen, we are going to be solving for volume. A 17.6 gram sample of aluminum has a density of 2.70 grams per milliliter. Would occupy how much space in liters? Okay? By the way, this problem here, they specifically ask for a certain unit in the end. We need to get our problem into that unit in the end when we are done, ladies and gentlemen. So keep that in mind. We need to get to that unit when we are done. Okay? Now again, ladies and gentlemen, we're going to use the same formula we have been using. That does not change here. Density is equal to mass divided by volume. We are given our density, 2.70 grams per milliliter. A lot of times with your problems, ladies and gentlemen, you just simply need to know where to put things. That is our density. 17.6 grams. What is grams a unit of measuring? What does grams measure for us? What does it tell us, Rocio? Grams is a what? Unit for mass or volume? Mass. So this is a mass, ladies and gentlemen. Even though it doesn't say this is the mass, by telling us that it is grams, that means that it is a mass, 17.6 grams. Now, what we don't have is we don't have the volume. Okay? We don't have the volume. All right? So, again, our problem is now to the point where we could solve it. We have one variable, v. We need to solve for it. Now, mathematically, with this one, we need to be careful. What do we need to do with v? Isolate it. But please be careful. Where is v at in this fraction over here? The bottom. I do not want to solve accidentally for 1 over v. I want to solve for v. So for me, the easiest way to do this is I'm going to multiply both sides by v. That gets it off of the bottom of the fraction for me. And now I'm going to take this side of the equation and I'm going to divide by 2.70 grams per milliliter. Why? Because that will get v alone over here. And what I do to one side, I'm going to do to the other. So ultimately over here, this cancels out and this cancels out. So v is equal to 17.6 grams divided by 2.70 grams per milliliter. Okay? What happens to the unit of grams here and here? They cancel out. Now, ultimately, you're ending up with this unit, 1 over 1 milliliter. When you take a number and divide it by a fraction, what do you actually do to it? How do you divide by a fraction? So we're going to take this, and this is going to end up with 1 times milliliters over 1, which is milliliters. I'm just showing you that to show you that, in fact, the units do still work out in this problem. You should always end up with a unit for a calculation. Now, someone, please take your calculator and take 17.6 divided by 2.7 and tell me what you get, please. Levi, I'm sorry, what is it? 6.52. What's the unit? Okay. Now, the problem is it wanted it in liters, correct? What is the relationship between liters and milliliters? 1 liter equals 1,000 milliliters. Okay? 1 liter equals 1,000 milliliters. So we are going to take this. We're going to put 1 liter on the top. We're going to put 1,000 milliliters on the bottom. Milliliters cancel and milliliters cancel. I am a huge fan, ladies and gentlemen, of letting units help me set up problems. Units will help you get the correct math. If your units cancel, you should be doing your math correctly. If your units don't, you're doing something wrong. Now, the final answer in this one, ladies and gentlemen, would be 0.00652 liters. Okay? In reality, there was no reason for us to put that into liters other than the question wanted us to, and just to practice that one conversion here. Okay? But we take 6.52 divided by 1,000, ladies and gentlemen. That's how we get this number down on the bottom. Questions? Okay, that is a quick review of density because we have done density before, ladies and gentlemen. We have done it before. Okay? Now what we are going to talk about is we are going to talk about specific heat. Okay? Now, specific heat is what we did at the start. The definition of specific heat is the amount of heat needed to raise 1 gram of a substance 1 degree Celsius. 1 gram, 1 degree Celsius. Okay, physical or chemical property. Is this a property that describes how matter reacts, or is it a property that you can observe without changing a substance? Nope, actually it would be physical. Because all you're doing is heating it up. If I heat up this tabletop, am I changing it in any way? Even if I melt it, am I changing the structure of what is there? No. Specific heat is a physical property. Does specific heat depend on the size of the sample? What?
Yeah.
No.
Because it's only how much?
Because it's
1 gram.
per gram per degree Celsius. Now, Levi, what does depend is how much heat I have to add to heat it up. That depends on the sample size. So when Leaf gave us earlier about this big object and little object, and we add heat to them, yes, the big object will not get as hot as the little object will. But their specific heats don't change depending on how much matter is there. They are an intensive property, yes. Come on up and grab one. Yep, okay. So it is the amount of heat needed to raise 1 gram of a substance 1 degree Celsius. Mathematically, heat or quantity of heat is equal to the specific heat times the mass times delta T. That triangle means delta. What does that mean? What does that triangle mean when you see it written in front of something like temperature? Thank you. It means the change in temperature. Okay? So in other words, depending on how much heat you add to a substance, depending on the mass of it, that's going to determine how much its temperature changes. Okay? That's going to determine how much its temperature changes. Go ahead.
I do that. How do you do the triangle?
Insert special character. So literally up at the top, insert special character. And then in the box, you can either type in delta, because that's what it is, or you can draw it as a triangle, and then it'll find one and you can input it. Okay? Now, this entire mathematical definition, we do not want to have to write this out all of the time. Okay? So what we do, ladies and gentlemen, is we use symbols to represent each one of these. I prefer using the term H for heat because it is the most common form of energy to add. However, some textbooks will use Q instead for the quantity of heat. I don't care which one you choose to use, but understand that either H or Q means the heat. Okay? Specific heat, its symbol is a capital C and a little p, and that goes back to something called specific heat capacity. Okay? That is a number that you can look up. You can go to a textbook and you can find the specific heat of a substance. So for example, copper has a specific heat of 0.386 joules per gram degree Celsius. Water has a specific heat of 4.184. Okay? Water's specific heat is much higher than copper's. Why? It is harder to heat up harder to heat up water than it is to heat up copper. The higher the number for specific heat, the harder it is to heat something up. Now, when do you want something that is hard to heat up?
Something's going to be in the sun.
When something's going to be in the sun, or we want something to not get hot. So things like rubber, things like plastic, things like wood that we use as handles on pots. What do you think their specific heat is? A high number or a low number? Theirs is a higher number. But things like glass, things like metal, things like ceramic that we use in cookware, What kind of specific heat number do they have? They have a very low specific heat number. Okay? M stands for mass. Delta means change, and T means temperature, ladies and gentlemen. Okay? All right. So, here's the variable or the factor. Heat, specific heat, mass, change in temp. Here are the symbols that we use. And here are the units that we use for each, ladies and gentlemen. Energy is energy. I don't care what kind of energy it is. Kinetic, potential, heat, friction, any kind of energy can be measured in joules. The only other unit that we really use in the United States to measure energy is what?
Fahrenheit?
What?
Fahrenheit.
That's temperature.
Or no.
Where do we get our energy from?
Oh, calories.
We get our energy from food, and therefore we will measure it in calories, ladies and gentlemen. Calories. Okay? Mass is still measured in grams. Temperature is measured in degrees Celsius for these calculations. Okay? You could do it in Kelvin. You could do it in degrees Celsius. You could do it in Fahrenheit, but most specific heats are written in joules per gram degrees Celsius. Okay? So this encompasses these three other units. Questions? Okay. So now, ladies and gentlemen, we are going to take a look at just two variables at a time. Okay? If we increase the specific heat, if we have water instead of sand, water has a higher specific heat. Okay? Now, we're holding constant mass and change in temp. Why? Because those are the other two things that are involved. Bless you. So if we want to change the temperature of water, the same as we want to change the temperature of sand, which one do we have to add more energy to? Water. So if the specific heat increases, the amount of energy that you need to add increases as well. What kind of relationship is this, ladies and gentlemen, if they're both increasing? This is a direct relationship. This is a direct relationship. Both those containers contain water. Because they're both water, they will have the exact same specific heat. What's the difference between those two containers of water? That's a factor for specific heat. What's different about those two containers?
One's bigger.
So what's different about them?
The mass.
The mass of water. The mass of water. So if I want to heat these both up 5 degrees, 5 degrees warmer than they are now, this one has a larger mass of water, this one has a smaller mass. To heat this one up 5 degrees, just like this one, what does it mean about the amount of energy that we need to add?
You have to add more.
We would have to add more. The amount of energy would increase. So if the mass of a substance increases, the amount of energy needed to heat it up to the same temperature will increase. What kind of relationship? That is a direct. That is a direct, ladies and gentlemen. Okay? That is a direct. Now, ladies and gentlemen, now I'm not comparing these two. Now I have that water there. Okay? That water there, same exact mass, same exact specific heat. Okay? If I want to make that heat up more, if I want to make that warmer, what do I have to do with energy? If I want the temperature to go up and up and up, what do I have to do with energy? Increase it or decrease it? You have to increase it. That is, again, a direct relationship, ladies and gentlemen. That is a direct relationship. Okay? That is a direct relationship. If I accidentally start a fire in this can from matches, what's going to happen to the can? Going to get hot. It's sitting on the tabletop, correct? Does the table get hot?
No.
Nope, not this tabletop.
It's a special tabletop.
Yeah, heat and acid resistant. Doesn't mean it can't heat up. Okay? But this will heat up almost instantly. This will not. Why? These two things have different specific heats. Okay? So which one of these has a higher specific heat? The can or the tabletop?
Tabletop.
The tabletop. Because it is harder to heat up. It takes more energy to heat it up. Okay? So, if both of these, the can and the tabletop, get exposed to the same amount of energy, because this has a higher specific heat, what will that mean for its change in temp? Will it be
It'd be low.
increasing or decreasing? What?
It'd be low.
It would be lower. It would decrease. It would decrease, ladies and gentlemen. Okay? If it decreases, ladies and gentlemen, what kind of relationship? That's our first inverse relationship. Specific heat and change in temperature in an inverse relationship. Higher the specific heat, the less the temperature change is going to be. Okay? So sand, which heats up very easily, low specific heat, high change in temperature. Water heats up very slowly. Low change in temperature, high specific heat. Okay? All right. So, I add the same amount of energy to both these waters again. Same amount. They have the same specific heat. If the mass increases, what happens to the change in temp from the same amount of energy? Which one heats up more? The smaller one. So the more mass is going to have a smaller change in temperature. Therefore, those are in a what kind of relationship? Inverse. Inverse. That is every possible relationship in a specific heat formula for you, ladies and gentlemen. Changing every possible variable, seeing how every other variable would react, and again, only changing two things at a time. So we can directly see, or we could see for sure, how one variable affects another. We're not changing 3 or 4 things at a time. Questions? Okay. So, here we go, ladies and gentlemen. How much heat does a 23 gram cube of ice absorb if its temperature increases from negative 17.4 degrees Celsius to 0 degrees Celsius? Okay? Water has a specific heat of 4.184 joules per gram degree Celsius. All right? So, ladies and gentlemen, there is our formula. Let's take a look at it real quick here. Okay. Formula for specific heat is this, ladies and gentlemen. H equals CP times M times delta T. By the way, ladies and gentlemen, it doesn't matter if I write the formula this way or if I do this. Write it whichever way you prefer. I don't care if you put the parts in parentheses. I don't care if you put a multiplication sign in between them. Either way, we're multiplying these 3 things together to get this one. Okay? So, our question, how much heat? Which symbol here, HCP, M delta T, represents heat? Which one represents heat? H. So, H is what we are solving for. H is what we are solving for. 23G. What is this? That's a mass. Negative 17.4 to 0. What are those? temperatures. Why do I need two of them?
Because you need to find the change.
I need to find the change in temperature. Okay? Need to find the change in temperature. By the way, there is technically a formula for the change in temperature. The change in temperature is equal to the final temp minus the initial temp. Okay? Final temp minus the initial temp. Okay? Final temp, 0.00 degrees Celsius. Initial temp, negative 17.4 degrees Celsius. What is our change in temp in this problem? Now let me ask you something. What's happening to the temperature change here, Jen? Is the temperature going up or down? Okay. So the only way you can make something's temperature go up is if you do what with energy to it, Jasmine? Do I add energy or do I remove energy to make the temperature of something go up? Add energy. So, because our change in temperature is positive, what does that mean for our energy? It's heating up. It's got to be a positive number. Okay? Can you have a negative amount of energy? Can you have minus 10 joules of energy? You cannot. You cannot have negative energy. There is no such thing. However, you can do what to something? You can take away energy. Now, in science, we very rarely use negative numbers. Temperature is one that you can have a negative number in. Negative 17.4. Okay? Can you ever have a negative mass? No. Could you ever have a negative specific heat? No. Can you have a negative energy? Technically, no. Okay? But what we can do is we can represent the way energy is going by using a positive sign and a negative sign. So if I am adding energy to something, that is going to be a positive amount of energy, correct? And what will happen to our change in temperature? You add energy to something, Daniela. What happens to its change in temperature? Does it get hotter or colder? What? It's hotter. They're both positive. If you have a temperature that goes down, what does that mean for the energy? That you did what? You took it away. So we can put a negative sign in front of energy, not to indicate that it's a negative amount of energy, but to indicate that we are taking it away from something. We are making it cool down. Okay? So you can use negative signs in front of energy in this case, ladies and gentlemen. All right. So this last thing right here, the CP of water, the specific heat is this. We can now plug everything into our formula. I'm solving for H. The specific heat, 4.184 joules per gram degree Celsius. The mass, 23.0 grams. And finally, ladies and gentlemen, the change in temp, 17.4 degrees Celsius. We multiply all three of these together. Now, what happens to our units over here, ladies and gentlemen? Over here, what happens to our units? Give me something about them.
Grams and degree Celsius cancel out.
This degree Celsius cancels out with this degree Celsius. This grams cancels out with this grams. What's the only unit I'm left with? What was the unit of energy? Joules. How many sig figs? How many sig figs? 3. 3 here, 3 here, 3 here, 4 here. Final answer should be in 3 sig figs. Somebody do the math of 4.184 times 23 times 17.4. Tell me what we get. 670? Good. You even put it in 3 sig figs for me right away. Very good. Questions? I warned my second semester classes about this as well, ladies and gentlemen. If you never do a calculation on your calculator until you actually get to the test, you won't know if you're doing your calculations right or wrong. I'm taking Levi's word that this is the correct answer, but since nobody else is bothering to give me any numbers, I guess we're going with it. Hopefully he's doing his math correct.
He's smart.
He's what?
He's smart. We trust him. We trust him.
Yeah, good.
Good.
Always good to trust somebody. Levi, you can take advantage of everybody in the room because they all trust you.
With math. That's it.
Just with math?
I don't know. He really helped us in our relay race.
Yeah, exactly.
All right, ladies and gentlemen. Take a look at this next problem. Good. Brenda, we're going to have you go start your quiz right away so that we get it done for sure. Okay? Ooh, Levi, wait a minute. 1,764, which rounds to 1,670. Very good. Very good.
Why did you do that?
Why did I do that? Because those of you who didn't bother to do the calculation are going to be, wait a minute, it didn't come out to 1,670. Why did he do that? Well, because we can only show 3 sig figs. The 7 is the 3rd sig fig. This 4 rounds down to a 0. You may trust him, but he knows his sig figs, so. All right, ladies and gentlemen, take a look at that problem. All right, Brenda, grab your periodic table if you'd like. And that should be the only thing that you need because there's no math on here.
What is this? Oh, is there
What?
Okay, so.
Answer key?
No.
Can I use this on the test? I need to leave.
The same here, and then match the, tell me whether this example.
This is so boring. I don't even keep one. My LEQ is really
Okay,
This is writing out.
so do we read the problem? Nah.
Yeah, I did.
Okay, so Brindley, give me one thing, okay, that relates to this formula from the problem. Hang on a second. The formula that we are going to use, H equals CP times M times delta T. So in the problem, where is one of those things? So pick a number. Pick any number in the problem. In the problem. There is no number 5 in the problem.
What problem?
Like
The one that we're on.
any of the numbers?
Pick a number.
Like any of them up there?
Yes.
She says 90.5.
Yeah.
Well, I was going to say 120 points.
Let her pick her own. Okay. What's the unit on that?
Grams.
Okay. What do grams measure?
Mass.
Mass.
grams?
That's my question.
So this
Sorry.
has to be the mass that we're going to use, correct? All right, Cynthia, since you want to yap so much, pick another number.
What the heck?
90.5.
Okay?
That's what I meant. You just never let me finish. I read my numbers backwards.
Yeah.
What?
Give her time.
Oh, that was the 5 that you had called out.
Yes.
Wait, so you do
Oh.
5.09?
Yeah. But
That's
No,
what
you
I was gonna
can't
say,
do
like,
that.
cut off.
Whatever. Okay, there's another one after that. What is the other one after that?
7.
No, stop. Don't even go there.
25%.
Okay, she doesn't read them backwards. What are those?
Numbers.
I know, but what do they represent based on their unit?
Change.
Temperature.
Temperature. So these two numbers are going to be involved in your change in temperature. All right, here's another number, 7,200 joules. 7,200 joules. Jacqueline. What? 7,020. What did I say? 7,200? Sorry, my bad. 7,020 joules. Okay, is that specific heat or energy?
Energy.
Energy. So we've got mass, we've got energy, we've got change in temp. What are we solving for here? Solving for specific heat. So we're solving for specific heat. Now, you have a choice, ladies and gentlemen. You can rearrange this formula to solve for specific heat and then plug in your numbers, or you can plug in your numbers and then solve for specific heat. I don't care which you do. Okay? Some people prefer to rearrange it when it's still variables. Some people prefer to put the numbers in and then rearrange it there. I don't care which one you want to do, ladies and gentlemen. But the H is 7,020 joules. The CP is what we're solving for, so I'm going to leave it. What was our mass again? Now, what was our change in temp?
Okay.
92.
I thought I was just stupid. In the 6 days.
So what is 90.5 minus 25.7? Oh my God, that's a tough one.
64.8.
Woohoo! Using your calculator, you are right on top of things, Cynthia. Beautiful. All right, now what do we do?
Distribute? We multiply.
Wait, I didn't do
I don't know.
See, this is the point where I'm telling you that it isn't science anymore. This has now become a math problem.
It's pretty easy. It's just
Good. Tell me what to do, Nadia.
from what? From right there?
Yeah.
You divide.
You have to
Divide. Divide what?
What if we got that
Well,
wrong?
you do both sides. The 2 times it first and then you divide both sides. Wait, no. Something like that, no? Yeah.
I'm listening to you. Go ahead. You tell me what to write and where.
I don't know. You multiply
just-
it first, and then you divide.
Okay. Do you multiply what first?
120.7 and 64.8.
Okay. Here's what I will tell you. Because of our new calculators, okay, and because you can go back to a calculation in them if you accidentally put something in incorrectly, you know what I mean, how you hit the up button and it'll take you back to it. When I do these problems, I prefer to do my math only one time. One time. You could multiply these two together and get a number and write it down. And then you divide this side by that number. But I don't want to make the mistake of writing a number down and then moving it over to the other side and maybe accidentally changing my number. Okay? I'm not going to put it into the calculator until I'm ready to solve for this. So what I do, and again, how you do your math is completely up to you. But I would take this side and I would divide it by 120.7 grams and 64.8 degrees Celsius. Get the CP alone. What you do to one side, I would do to the other.
So basically, you just multiply. Basically, you just move the numbers to the other side. You don't gotta
You're-
make that complicated.
You're always the term that I learned 400 years ago when I was in math was isolating the variable. Okay? Singling it out, getting it alone, however you want to say it. I need CP on this side alone to be able to solve for it.
Yes.
Come on, Brenda.
Wait, is your answer like 0?
Hold on, what?
Is that answer 0?
I don't know what the answer is. I haven't done the math. Okay? I have not done the math. But here's what I know that we needed to do. We needed to get specific heat alone on one side. Now in your calculator, take 7,020 divided by 120.7 times 64, and that you have to put in parentheses on the bottom before you multiply it together.
Shoot, you're right.
And now Someone give me the answer, please.
4.
Oh, I thought without. I'm the answer.
33.45.5. I'm just kidding. I just made that.
What?
I'm gonna bet that that's right. Wouldn't that be funny if you were right? I would just like randomly.
Where are we?
What do you mean, where are we? Levi, have you not been paying attention?
In the
No, you guys haven't been. You guys have been sitting there having your own conversation while we've been going through this. But hey, I assume you know what you're doing, so that's the main thing. Go ahead.
I don't know. I think it's wrong.
Good. Put away your phone then and get out a goddamn calculator. And the rest of you who are just sitting there doing nothing, you're going to mess this up on a test. Because if you do not try to do these calculations, you're not going to put this into your calculator correctly. And even though you put the same 3 numbers in it, you may get 2 different answers from somebody else. You have to learn how to use your calculator. 7,020 divided by parenthesis 120.7 multiplication sign 64.8. Close the parenthesis. Excuse me, Mr. Brandon. I do. You bet. Okay, bye. Leave. Career Center, go.
3768.81.
3768. Can you read that to me as a number, please?
No, I don't know how to read this. 3768.81.
No, not even close. I'll tell you that right now.
I think you said you didn't know the answer.
I don't, but I know that is not even close.
I don't know how to write this one.
I should try.
Brenda,
I don't know if it's right. I did 0.897.
that sounds reasonable.
I got that.
Now,
Isn't it?
Cynthia,
Just
Okay.
I had it.
Hold on. Hold on. But why did you give me 3,700
I
and some?
gave you right.
See, but here's the thing. You don't even, again, ladies, gentlemen, listen.
I did.
Listen. Listen. When she did the math and she gave me the numbers, she's like, well, how do you know it's wrong if you didn't do the math? Here's how I know it's wrong when I didn't even have to do the math. 100 times 64 is what? 6,400. 7,200 divided by 6,400 is about 1. You gave me a number 3,700 and some. I knew that wasn't right without doing it. Now, this doesn't come out to be about 1. It comes out less. Brenda, your number is absolutely correct. But again, by simply doing a little bit of estimating with the numbers, I realized that this bottom was about 6,000, 7,000. That's 7,000. This number's got to be 1. Now, what happened with your calculator, Cynthia? You took this number, divided by this one, and then you hit times this one. So your calculator took 7,000 divided by 120. Got you to probably about 60 some, and then took it times 60 some to give you 3,700 and some. Order of operations in your calculator. It does what you tell it to do. When you have 2 numbers on the bottom here, ladies and gentlemen, you need to put them in 1 set of parentheses if you are going to multiply them together. Now, you could do this with your calculator, Cynthia. You ready? Take 7,020 divided by 120.7 divided by 64.8. And now you're going to get 0.8 something. Right? Got to figure out how your calculator works, ladies and gentlemen.
I did it, but I thought that was wrong, so I didn't say it. But I did it on my phone, but I don't know how I did it.
I believe you.
Thank you.
What was the final number? I'm sorry again, Brenda.
0.8982.
What's the next digit, just so I know?
It was
Oh, but
7,
it's-
9,
Okay, 0.879.
8, 9, 7, 9.
Okay, it's 0.8975.
Okay, which we've rounded up to 0. Thank you. That's all I wanted to make sure of. What's the unit?
Joules per gram Celsius.
All of them. They stay.
Whoa.
You
We're
can't
not
cancel
struggling.
any of them out.
It's okay.
And that's the unit we get for specific heat. Joules over grams times degrees Celsius. We cannot cancel any of them out. Questions? Markers are on the back. Sheets are at each table. Go practice some problems. I don't know what went wrong here.
What am I gonna do?
Can you give the whole lesson again?
It's all videotape for you. Watch it tonight.
Oh, I forgot it's video.
You need a calculator. Take one with you. If you don't have one, come up and get one of mine. Do not use your phones. You can't use them on a test anyway. Be careful of the bucket over there. I'd hate to see you kick the bucket, Cynthia.
Kick the bucket.
Oh my God.
Okay, that's so funny. 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 I laughed really hard.
Wait, are we taking this?
Okay, do not take the answer sheets, but when you're done doing your problem, take the answer sheet to your desk, see if you got it right. If not, call me over and I'll help you. If you got it right, move on to the next one. By the way, for erasing your work, ladies and gentlemen, the sponges or the erasers are right here. Just come up, rinse it out, take one of these to your desk, and you can wipe off anything that you don't get correct. Okay?
Let's do this, y'all. Let's do this.
You better, because in 2 days you're going to be asked to do this on a test.
What?
Start with
How
number
is
one.
it gonna help me when I graduate?
Do number one.
How do I?
Well, how's this going to help you graduate? If you don't pass this class, you may not graduate.
No,
So,
I
this
said after I
is,
graduate.
I don't know, what are you going to do with your life? How do you know? Okay. Well, then I don't know why you took the course.
Because I have to.
Why? What are you going to be?
Because I'm not.
Is it gonna be a
Do
nerd?
you have to take chemistry?
No.
No.
They took physical science. We have to take
Why am I
chemistry
here?
because we didn't take physical
I
science.
have to take.
Well, that was your choice, but yes, okay.
Yeah.
Why am I here?
You have to take this.
I have to. You take it in high school or college, or is it in high school?
Right.
Why?
And then what? I didn't. I had to take biology.
No, it's the density of the
You did.
What is my?
Answer keys are right here. Just make sure when you do check your answer key, ladies and gentlemen. You know which version of questions you have. Do you have A, B, or C? And then which one are you checking the answers on? Yes. Okay.
Now?
Oh, that's correct.
But your brothers?
What's the volume?
Okay. Set it up. Okay, so now we've got V over here, but it's not alone. How do we get V alone? What do we do? What?
So math. So then I do.
Well, to get it's not because it was on the bottom here, we multiplied by it. Right? Okay, so we're supposed to multiply by this. How do we get rid of this if we're supposed to multiply by it?
Are you sure?
Oh, yeah. I was like, what? I don't know what I'm looking at. Yeah. That's right.
What you do to one side of
And
an
then I just
equation,
go.
you do to the other.
And then I.
So this
Do
now
I
cancels.
multiply this?
So V is equal to all this is math to get this alone so that we can solve for it. Okay? Let's see it again. It will be up there. You don't understand.
Look, I'm doing this, but I'm searching up how to do it.
It isn't gonna help isolate the variable. Get V or
How
off.
to. I just divide it.
Where's it at in your problem?
It's because
Okay,
it's
so you wanna get it alone, so multiply both sides by V.
Yeah.
Don't put an equal. Multiply both sides by V. Okay? So now rewrite your equation.
Wait. Do I?
That's really big.
Ah, what are you putting in? Whoa.
Oh shoot. Deleted it.
Yeah.
Okay,
Do I do the suffix of this or this?
Okay.
Do the lowest amount.
So now, what unit is 70.92?
So just 11.
Okay. No, not grams per centimeter.
That's 3 centimeters. Not the lowest number.
Okay.
Yeah, so this one.
Yes, you're doing this one, but there's 3
Why are you dividing by 70?
Because I'm dividing this one.
No, stop!
So is it
This
this
can't
one?
go.
Then you got nothing on that side. You want to get B alone.
These are. Oh, I'm doing it.
And now you're erasing into the stuff that you still needed.
No, I know.
Okay, good.
That's it?
Make sure you put your thing.
What?
Your.
Oh.
If you want me to take a look at them, I will definitely take a look at them. If you have questions, I will answer them. Sure. Okay, well, let me ask you this, what's using it to measure mass? As long as grams is part of this unit, yes, this and this.
Like how do you
So, here's the thing, the only unit that we're not sure, well,
do you know what it's
volume can be in multiple units, it can be 7 meters cubed, it can be milliliters, milliliters. Mass always has to be grams. I'm not gonna have a problem with it, kilograms, okay? Which means density is always grams over centimeters cubed, milliliters. Okay? Again,
I can't do that.
you don't have to show me how you're canceling out units, but in the end, you need to make sure you find a unit that has the right.
Oh, you can speak.
Okay.
Audio, yes. Audio.
What did you do wrong? You didn't do it wrong, but what you ended up is this is equal to 1 over B. Because B never got off the bottom. Okay, so we could take the reciprocal of this side, and if we take the reciprocal of that side, that number times 10 to the negative, or times the negative first, will give you an answer. Hang on 1 second. Oh, Mr. Brandon. Yes, I do. You want just all of them or what? Please, come on, take them all, then I don't have anything to do. Okay, bye. Okay, so I kind of lost you there, didn't I? Okay. I brought your thing, then you gotta go downstairs. What's the person? I don't know, she doesn't tell me, she just says, just give me that. So right now we have this, okay? So what we want to do is to get B on the top, we're taking this and we're doing the reciprocal of it. So we want B over 1. So what we do to one side, we do to the other.
And then I
Okay.
this.
So now if we do on your calculator, this is the reciprocal button right here.
I kind of got it.
Not, oh, right, it's yours is good that way. I don't like that. So 311 divided by 20. So the good news is, unit would be centimeters cubed. The good news is everything you did correct. You just accidentally solved for that. Okay, you did that. Grab your stuff, head down to the cursor.
Okay, and then.
Please make sure when you put my markers away, to make sure the caps are on tight, don't just put them on, make sure they click. Because otherwise they dry out and then I have to throw them out and then I don't have markers to do this with you guys. Okay?
Hey, can you help us?
Okay, so for these, this is specifically around here. Okay? So the 3 kilojoules of energy, that's H. But we gotta get it into joules. Okay? We gotta get it into joules, not kilojoules. Okay? And then which other number?
Wait, it's just like this?
17.0. That is going to be the temp, but for this problem, when you put this here, you're gonna solve for temp, yes. And then in the end, what you end up having to do is add that to that number. So you solve for, well, what I would just do is I would just put delta T there. and I would solve for it. Over here,
Those points.
Oh, wait,
6
you
or 3 kilojoules is 3,000 joules. Multiply that by 1,000. Nope, multiply by 1,000.
Yeah?
I think I need one.
One more.
Okay,
Joules.
and then.
And now it equals this. Now you've only got one variable you're solving for. That.
Oh, wait, no, I didn't.
Who called?
So then I just divide that.
Yes, what do you need? Okay.
How we doing?
By the way, we only have 2 minutes left to class, so it's up to you if you want to start another problem or not. When you're done, please put everything back where it was. Please put your ranks back in the bucket. Please clean up your station so that there's not writing all over the desk for my next hour when they come in to work on their problem. Okay?
Te duermes así.
So right.
Okay, so you already did that? Never mind. When you put that 10.88 in there, I was thinking.
Here, Nate, I'll put away your marker for you. Thank you. Thank you.
Really saturated. Very saturated. No, she walked away.
See?
I wasn't.
Don't be a weakling. Don't be a weakling. Goodbye, ladies and gentlemen. We'll see you tomorrow. Goodbye, goodbye, goodbye. Go make it out. Thank you. Thank you. Could be worse. I don't know how, but it could be.
Jose Dubana, Costa,
I can't.
Antonio Thomas.
Goodbye, ladies and gentlemen. We'll see you tomorrow. Goodbye, goodbye, goodbye. Go make it out.
I'm not ready. Shoot.
Bang, bang.
That's not
Bang.
What's it?
because I say shoot. And
Oh,
then
I was like, what?
bang.
I was like, what?
It's a little funny thing.